We are going to talk about angle relationships and parallel lines. So the first thing we're going to discuss is just some of the basic angle relationships. We've already talked about vertical angles, so if you have an angle or angles formed by two lines that are intersecting, then the opposite, or the angles that are across from each other, they are congruent. Then we're going to move over to adjacent angles. This is a new term, but adjacent just means beside or next to. So if two angles share a side, then they are adjacent. So for example, angle 1 is formed by these two lines and angle 2 is formed by these two lines. They share this side. So since they share a side, they are adjacent. So angles 1 and 2 are adjacent. Angles 3 and 4 are adjacent. Angles 4 and 5 are adjacent, and angle 1 and angle 5 are adjacent. Next, complementary angles. They are any two angles that add to be 90 degrees. So I have another diagram on the screen here where your angles don't necessarily have to be touching. So these two angles, A and B, they are marked as 30 and 60 degrees. So 30 and 60 is 90. That would mean A and B are complementary. However, if you do have the angles that are touching, that's fine. As long as they add to be 90 degrees, that makes them complementary. So these two lines form a right angle. That's noted by the little box here. And angle 1 and angle 2, since they form that 90-degree angle, they are complementary. Next, we have supplementary angles. They are any two angles that add to be 180 degrees. So again, I have a diagram on the side showing you that those angles do not have to be touching. They can just be any two angles. So if you have a 50 and a 130 degree angle, they add to be 180. They are supplementary. Likewise, if you have two lines that are intersecting, any two angles that form a straight line are supplementary. So angle 1 and 2 form a straight line. And what I mean by that is we have this angle 1, and then we have angle 2, and together they make this straight horizontal line. So since they form a straight line, any straight line is 180 degrees. So 1 and 2 are supplementary, 2 and 3 are supplementary, 3 and 4 are supplementary, and 4 and 1 are supplementary. All right, and then finally a linear pair that's kind of a combination of adjacent and supplementary. So every linear pair is supplementary because it forms a straight line. So angle 1 and angle 2, they share a side, so they are adjacent, but they also form a straight line, so they are supplementary. And that makes them a linear pair. So again, angle 1 and 2, angle 2 and 3, angle 3 and 4, angle 4 and 1. Those are all pairs of linear pairs. Now we're going to look at some more detailed relationships between angles, and now we're going to look at, we're going to throw in some parallel lines and some more vocabulary. So I have this diagram here. I'm actually going to erase this and we'll kind of start over with this conversation about corresponding angles, which is one of the most basic relationships. But before we do that, I want to talk to you about some vocabulary. So up at the top here, you see I've got line M is parallel to line N. So this symbol that looks like two L's means parallel, and a parallel mark or notation is just these two little arrows on the parallel lines. Okay, so that's one piece of vocabulary. Line L is what we call a transversal. So a transversal, it's just a line that goes through two sets of parallel lines. So line L crosses over M and N. Since M and N are parallel, then L is a transversal. Okay, now we can move into this idea of corresponding angles. So when you have parallel lines cut by a transversal, you have two intersections. So we have the top intersection and the bottom intersection. And those intersections kind of create like 4 corners, if you can think of it that way. Okay, so there's 4 different little corners formed by those intersections, and basically corresponding angles are just the angles that are in the same position. So angle 1 is in the same position as angle 5, right? They're both in the top left of the intersections. Then angle 2 is in the same position as angle 6. They're in the top right. Angle 3 is in the same position as angle 7. They're in the bottom right. And then angle 4 corresponds to angle 8. Now, corresponding angles, these angles that are in the same positions, they are congruent. So as long as you have 2 parallel lines that are cut by a transversal, then the corresponding angles are congruent. So 1 and 5 are congruent, 2 and 6 are congruent, 3 and 7 are congruent, and 4 and 8 are congruent. All right, moving on to interior angles. Interior angles is hopefully pretty easy to remember. It's just the angles between the pairs of lines. So if we have M is parallel to N, then the interior angles are all the angles that are sandwiched between those 2 parallel lines. So angles 3, 4, 5, and 6 are all interior angles. Now, a little more specifically, you have something called consecutive interior angles. That just means that they are on the same side of the transversal. So you have, again, that yellow region represents the interior angles. Then the transversal, the line that splits, or the line that goes through the 2 parallel lines, that cuts the yellow region into a left side and a right side. So the consecutive interior angles are going to be the pair that's on the left and then the pair that's on the right. So the pair on the left is angle 4 and 5. The pair on the right is 3 and 6. They are 2 sets of consecutive interior angles. Now the theorem that goes with this is that consecutive interior angles are supplementary. They add up to be 180 degrees. Now, the reason that happens, we're going to actually look at that a little bit later, but for now, I'm just kind of giving you that exposure, that 4 and 5 are consecutive interior angles, so they add up to be 180 degrees. Okay, another word that you might see instead of consecutive is same side interior. It means the exact same thing. I just wanted to show you that if you see the words same side interior, that means the same thing as consecutive interior. Okay, so now instead of having consecutive interior angles, we have alternate interior angles. So again, we're talking about interior, so we're in between the 2 parallel lines. But instead of being on the same side, they're actually in the opposite locations. So for angle 4, we have, that is located in the top left of the yellow region, right? Well, the opposite of the top left, if you want to think of it that way, the opposite of top left is bottom right. So these 2 are alternate interior angles. Also, you can do it from the other side. So angle 3, which is interior, it is in the top right. Well, the alternate of that is going to be the exact opposite. So the bottom left. Okay, now alternate interior angles are congruent. So angle 4 is congruent to angle 6. Angle 3 is congruent to angle 5. Okay, let's make some connections with all of these. So starting with Okay, let's make some connections between what we already know about vertical angles, what we now know about interior angles, alternates corresponding, all of those. We're going to kind of tie them all together. All right, so starting with angle 1. Okay, angle 1 is vertical to angle 3. So these two are congruent. Okay, so I'm going to start with just that. Angle 1 is congruent to angle 3 because they are vertical. Okay, now from angle 3, that's an interior angle. So we know some things about interior angles. We know that, I'm going to do this in a different color so you can see the difference. We know that if this is in the top right, then the opposite or the alternate of that, the bottom left of the interior, these are alternate interior and they are congruent. So angle 3 is congruent to angle 5 because these are alternate interior angles. Well, angle 5 is across from angle 7 because they are vertical, so they are congruent. So angle 5 is congruent to angle 7. So all of these angles are congruent to each other because of the vertical and the alternate interior angle theorems. So it kind of makes this zigzag pattern. Now you could do the same thing in the opposite direction. You could start with angle 2, right? So that's vertical to angle 4, and that's an alternate interior to angle 6, and that's vertical to angle 8. So all 4 of those are congruent as well. So not only can I list out all of these statements, I can simply say that angle 1 is congruent to angle 3, angle 1 is congruent to angle 5, and angle 1 is congruent to angle 7. They're all equal to each other. So angle 1 is congruent to angle 3, which is congruent to angle 5, which is also congruent to angle 7. So this is going to lead us into some exterior angle theorems. But I also want to make a connection to the corresponding angles that we talked about before. So remember, corresponding angles mean that they are in the same position of the intersection. So if we think about like angle 2 and angle 6, they are corresponding because they're in the top right of each little intersection that's formed. Right? Well, based on these connections between vertical and alternate interior angles, angle 2 is also congruent to angle 6, which we just saw that because of the zigzag pattern that it creates. All of those are equal to each other. But this theorem is the corresponding angles theorem, and that's where it comes from. Okay, so all of the corresponding angles are congruent because they are vertical and or alternate interior angles. Okay, now we're going to talk about exterior angles. Okay, so exterior angles are, they're on the outsides of the parallel lines. Okay, so that means they are above or below the parallel lines. So that's angles 1, 2, 7, and 8. Okay, now same side exterior. So we're on the exterior, so we're above or below the parallel lines, but on the same side of the transversal. Right, so if they're on the left side, that would be angles 1 and 8. They are same side exterior. And then if they're on the right side, which is angles 2 and 7, they're same side exterior. And same side exterior angles are supplementary. So let's think about, we just said that angles 2 and 6 are congruent, right? So if this is basically just angle 2, because they have the same measure, then angle 2 and 7 form a linear pair, right? These form a straight line. So 2 and 7 form a 180-degree angle, which means that they are supplementary. So all of these same side exterior angles are supplementary. Okay, alternate exterior angle. So same idea as with the interior ones, it's just that now we're on the outside, so we're above or below the parallel lines. Whoops. So we are either above or below. Now, when we're thinking about alternate, remember that means the opposite. So if angle 1 is in the top left, then its alternate is going to be the bottom right. Okay. And alternate exterior angles are congruent. Again, that's because we talked about, remember, so 1 is congruent to 3, 3 is congruent to 5, and 5 is congruent to 7. Well, if that's the case, then that connects angle 1 and angle 7. Okay, same thing with angle 2. We have top right. So its alternate exterior would be the bottom left. And they are congruent. Okay, and that's all of them. So we're just going to kind of summarize now to kind of keep it organized in your brain. So the interior angles are always between the two parallel lines, right? So that looks like this. They're the ones that are always right there in the middle. Okay, and there's typically a label for each of them. So you've got those four angles. They're either consecutive or same side interior, which means that they're on the same side of the same side of the transversal. If they are consecutive, same side, they are supplementary. So think same side, supplementary, kind of runs together. Alternate interior, so if they're alternates, they're congruent. Okay, so same side, supplementary, alternate is congruent. All right, now if you have the exterior angles, remember those are the ones that are on the out. Now your line can be going this way, so I just want to make that clear too. It doesn't always have to look exactly like this. But the alternate or the exterior angles are either above or below. So it's those four angles there. 1, 2, 3, 4. Okay. So if they're the same side, they're supplementary. If they're alternate, they're congruent. And from the combination of all of these, we get that corresponding angles are congruent. And we talked about a little bit of vocabulary. So if you see a line drawn above a letter, that is representing the line of that letter. So line A, the two long straight bars, they are the parallel symbol. And then a transversal, if you see that word, it's just a line that goes through two parallel lines.